Okay, so in this video we're going to be learning how to solve linear inequalities by graphing, okay? So, we already did systems of linear equations. This is systems of linear inequalities. So, of course you could always, make them equal to each other. However, in inequalities, they're actually different, because it's a solution set. If you don't know what a solution set is, that's basically like if I say, oh, it's from negative infinity to 6, and we all know that, it's all numbers that are negative and then all the way to 6 or something, or if I say, oh, it's from 1 to 6, it's 1, 2, 3, 4, 5, 6. So basically that's what a solution set would be. So in this first one we have y is greater than 1/2 x plus 2 and y is greater than or equal to negative x minus 1. One of the things that I want to do first is I want to graph both of them. So basically, one of the things to keep in mind about this, you want to make sure that you actually graph both of them like right away, because if you only graph one and you shade it, it can mess up the other one, if that makes sense. So first we're going to graph this one right here, this first one. Okay, we have 1/2 x, y is greater than 1/2 x plus 2. So we're going to plot our y-intercept. Our y-intercept is 2, 0, 2. And then we're going to go up 1 and to the right 2. So it's 1 up and then to the right 2. Okay. And we're just going to keep doing that for this one. So it goes 1, 1, 2, 1, 1, 2, up 1, 1, 2, and then for this other part, we're going to go down 1 and left 2, okay? So it's 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, okay? And then it's greater than, so it's when it's greater than, it's going to be a dashed line, okay? So, okay, so just wanted to reiterate that. So we have something like this, or some of you may call it dotted line, I call it dashed line, just because to me it looks like that. And then once you do that, you graph your second one, which is y is greater than or equal to negative x minus 1. Okay, so you're not shading yet. You're going to shade until the end, okay? So we have our y-intercept right here, and it's greater than or equal to, okay? So it's going to be a line. So you're going to go down 1 and right 1, because our slope is negative. It's rise over run, so it's down 1 and to the right 1. Down 1, right 1. And then and then up 1, left 1, okay? Up 1, left 1, up 1, left 1, and then up 1, left 1, up 1, left 1, up 1, left 1, okay? So, once you do that, you're going to go ahead and do a line, because it's greater than or equal to, so it's a line. So, you have something like this, okay? And then once you have that, you do your test point, which is 0, 0. Okay, so remember that in any inequality, when it satisfies the equation, that means you're shading in that area. Okay, so let me explain what that means. So if you have, for example, if you have so we have y is greater than or equal to, or rather, y is greater than 1/2 x plus 2. Okay, so we're going to do 0, and then we're going to put a question mark. Is that greater than 1/2 x, or 1/2 times 0 plus 2? 0, is that greater than 0 plus 2? 0, so 0 is not greater than 2. So because it does not satisfy that solution, we cannot shade where 0, 0 is. So we're going to shade above this line. So you would grab your pen and you would literally shade this entire part right here. Okay? You would shade this entire part. And then we have another one that says y is greater than or equal to negative x minus 1. Well, we're going to do the same thing. We're going to test 0, 0. So we have y is greater than or equal to negative x minus 1. So then we have 0. We're going to plug it in. Is that greater than or equal to negative 0 minus 1? So it's going to be 0. Is that greater than or equal to 0 minus 1? So 0 is greater than or equal to negative 1. Okay, so that means, what that means for this one is that for this part right here, we shade let's see, we shade, I think, above. Yeah, we shade above. So we do above this line right here, and then we're going to do another color. Let's just do green, for example. If we do above this entire part, because it is a solution, all of these are a solution, we have all of this for green. So in reality, our inequality states that if we were to make this, if we were to do this for if we were to solve this, basically this entire part right here where it's both shaded on both sides for black and green, this would be our actual solution right here, because it is both black and green, okay? And if basically that's what the inequality states, is that all of these are the solution. And let me just double check to make sure that's correct, because let me just make sure. Give me 1 second, guys. 1/2 x plus 2, and then y is greater than or equal to negative x minus 1. Okay, so yeah. So that means that this entire area is a solution. If you want an actual representation of that, let's just, for the sake of it, graph it. And then y is greater than 1/2 x plus 2. Okay, so you see this entire area that's red and blue? This entire part right here is your solution set. So basically that's what basically that's what that's how it would look on a graph if you were to just graph that part. And since we already did that over here, we can go ahead and delete this and this, and all we have to do is make sure that both of these are graphed, so like this. So it's like red and green, or sorry, black and green. As long as it's actually, as long as you show that it's the solution. You don't really have to graph both functions, but as long as you graph the solution. That's why when they ask you to do these, they ask you to show on the graph that this is true. So yeah, that's how you graph this inequality. And then I'm going to go through one more. So sorry guys.